Hello guys, welcome back to the channel Mathemagix JEE. This is the next problem, question number 8. For a function fx, let di fx divided by dxi, okay? So it denotes ith derivative with respect to x at x equal to a, okay? Consider the m by n matrix A equal to aij m cross n, where aij, the matrix elements, are calculated using this formula, okay? This is ith derivative of x to the power m, and here it is jth derivative of y to the power n at x equal to 1 and y equal to 1. Okay, let pi be maximum of all the elements of this set. Okay, so in this set we have total n elements. This set contains a I1, then AI2, AI3, and so on up to AIN. Okay, and Qj is minimum of all the elements of this set. This set is what? This set is, if we expand, A1j, then A2j, A3j, and so on up to AMJ. Okay, P is the minimum of Pi, where I equal to 1 up to M, and Q is maximum of Qj, where J is varying from 1 up to N, right? Then which of the following statements is oblique are true? Okay, so let us first construct this matrix first, okay, or have a brief outline about what the elements are. So let us first focus on this relation, given relation, okay, Aij. Aij is the element of ith row and jth column of this matrix. Okay, so aij is nth, or we can say ith derivative of this x to the power m, right? So we can observe a pattern here that if we take this function x to the power m, then differentiate this function single time, we get, if we calculate the derivative at x equal to 1, okay, so we get it is m into 1 to the power m minus 1, that means m. So if we calculate the double derivative at x equal to 1, we get it is equal to m into m minus 1, right? And similarly, we can say by the pattern here at x equal to 1, we can say di dxi x to the power m will be nothing but m into m minus 1 into m minus 2, so on up to m minus I plus 1. Okay, so we can write this as m factorial divided by m minus I factorial. Why? Because I simply multiplied and divide this term by m minus I factorial. Okay, then we got this relation. Now again we can further multiply and divide by this I factorial, right? So that this term here will become our MCI, which is the binomial coefficient. So we can say that we have this Aij as I factorial MCI divided by J factorial NCJ. Okay, so this is our Aij. We decoded it. Now let us decode these sets. Pi is maximum of AI1, AI2, AI3 up to AIN. Okay, so let us calculate this Aij. Okay, this set. So if we calculate AI1, for example, AI1 will become I factorial into MCI divided by 1 factorial into NC1. Okay, so it becomes N simply. Similarly, AI2 will become I factorial MCI divided by 2 factorial into NC2, right? So 2 into NC2 is N into N minus 1 divided by 2. That means it will become N into N minus 1. So we can say that what will be the maximum element of this set. Okay, so Pi is collection of all Aij's where I remains constant but J varies, right? So now tell me, if I is remaining constant, this numerator is remaining constant, right? So if the numerator is remaining constant, we will get our maximum element aij when this denominator is minimum, right? So we can say clearly this maximum of pi, here we are asked to find sorry, maximum of pi, not pi will be maximum of this aij. Okay, so pi is maximum of all these elements. That means it will occur when this denominator is minimum. Okay, that means denominator is minimum when j is equal to 1. So we have pi as ai1. Now let us similarly decode this qi. Okay, so qi is what, sorry, qj is what, minimum of aij where I is 1 to up to m. So qj is the collection of all aij's, okay, where j remains constant but I varies. So we can say clearly that this qj is minimum of all the elements. Okay, so we can say qj is minimum of aij, I equal to 1 up to m. So when will this minimum element occur? Here we can see easily this j remains constant, that means the denominator is constant. So the minimum will occur when the numerator is minimum. So in this case the numerator is minimum at I equal to 1. That means we have a1j. Okay, so we decoded pi equal to ai1 and qj as a1j. Okay, so we can find these values easily from here. ai1 we already decoded, is it is equal to I factorial mci divided by n. And similarly we can calculate this qj. Here qj is a1j, so a1j will give us m divided by j factorial n cj. Okay, so now we are told that p is equal to minimum of all those pi's. That means we have to find again the minimum of all these elements, all these pi's. Okay, so we can say clearly this denominator is constant, so pi will be what, minimum, right? So pi will be minimum when I is again minimum. That means I should be equal to 1. So p will be p1, which is equal to 1 into mc1, which is m divided by n. And similarly q is maximum of all these qj's. Okay, so we can say maximum element will occur when j is equal to 1, that is the denominator is minimum. So q is q1. Okay, so q is q1, that means m by n. So this is equal to p, this is equal to q. We found this p and q. Now let us check these options. So in the options if we check, we can see p greater than q, this option is false, right? Because p is equal to m by n and q is also equal to m by n. That means option a is not correct. Let us check option b. Option b is saying a11 less than a22 less than so on up to a okay, if n greater than n. Now focus on this aij. Okay, so let us focus on this part. So we can say a I. Let us calculate this, okay? Because in the option we are given this format I, where this I is equal to j. That means we can put I equal to j equal to some I. Okay. So ai is basically I factorial mci divided by I factorial nci. So I factorial will get cancelled. That means aij is mci divided by nci, right? Now think about this. If m is greater than n, according to the given option here in the question, it says m greater than n. That means we can say this mci will always be greater than nci, right? Because we know this ncr, this binomial coefficient, is increasing function with respect to this variable n, right? For example, we can take 3c2, this is equal to 3, but if we take 4 here instead of 3, we get 4c2 equal to 6, right? So if m is greater than n, that means mci is always greater than nci. Now again we can say that if I change this r here of this binomial coefficient, right? So let's take some 5c2. Okay, 5c2 is how much? It is equal to 10, right? And let's take 6c2. So 6c2 is definitely 15. Now if I change this r here, that means we take 3 instead of 2 here, 5c3 is equal to 10 again, right? Because 5c3 is equal to 5c2, and 6c3 is coming out to be 20, right? So we can say by observing this pattern that this mci divided by nci, which is aii here, right? So aii is always less than ai plus 1 I plus 1, right? So this statement which is given in the option B, it is true. And for option C, if we check amn, am minus 1, n minus 1, we have to compare them. Okay, so let us compare this. So let us do this here. Amn, we can calculate amn is equal to m factorial, then mcm. So overall m factorial divided by this we can write as n factorial ncn, so n factorial, right? And similarly if we calculate m minus 1 and n minus 1, this element we get, it is equal to m minus 1 factorial times m c m minus 1 divided by n minus 1 factorial n c n minus 1, right? Now if we simplify this binomial coefficients, we get this, we can write as mc1, right? And here we can write this as nc1. That means it will be m into m minus 1 factorial, that means again m factorial, and it will be n into n minus 1 factorial, that means n factorial. So we can see clearly for upcoming terms also that amn is equal to am minus 1 n minus 1 equal to so on. Okay, and where would this series stop? This series will stop when this L is equal to minimum of m comma n, right? Because if let's say we exceed this number, we will not get any positive value of this index, right? So that is not possible because we are dealing with a matrix. So the row and column indices are also positive. That means here option C will be definitely correct. And for option D, we can check by plugging in m equal to n, right? So we get a ij is, it is for option D, right? So A is symmetric matrix if m equal to n. Okay, so let us calculate this matrix m equal to n. If we put in this relation, we get I factorial divided by j factorial into this will be mci divided by mcj, right? So mci divided by mcj. So we can, for example, take a 3 by 3 matrix. Okay, 3 by 3 matrix we take as A. So then we calculate this A12 and A21 and A12, right? So let us calculate this so that we can verify whether it is true for a 3 by 3 matrix. So A12, if we calculate, it will be, so we are dealing with m equal to 3, right? M equal to 3, that means 1 into 3c1 divided by 2 into 3c2, right? So this is 3, this is also 3, that means it will cancel each other, it is equal to half. Now let us calculate this element, right, which is the mirror image about this principal diagonal. So A21 is how much? It will be 2 into, this will be 3c2, that means 3c2 divided by 1 into 3c1, right? This is equal to 2. But if A was a symmetric matrix, it would have been same as A12, right? This A21 would have been same as A12. But that is not the case. That means we found an appropriate counter example to this statement. That is why this statement is false. So A need not be a symmetric matrix. Okay. So A is a symmetric matrix if m equal to n. This statement is wrong. That means our correct option for this question will be option P and option C.